In this video, we're going to talk about combining functions to form a new function, in particular using the arithmetic operations addition, subtraction, multiplication, and division. So we're going to define what it means to add, subtract, multiply, and divide functions. We're going to show how to combine some example functions computationally and from their graphs, and then we're going to do an example of an application that you get from combining functions. So let f and g be functions. We define the following functions. So before I get into actually how to define these different functions, let me talk a little bit about how you define a function. We define a function depending on what the inputs are and what the outputs are. So if I tell you a function, what to do with its inputs, how to make outputs, that's defining the function. So for instance, if I wanted to tell you what the function f plus g is, I would have to tell you, okay, if I give an input to f plus g, what's the output I get? Well, if x is the input, so I'm taking f plus g of x, then in this case, the output is just going to be put in x into f, put in x into g, and then add those two together. So the input is x, the output is f of x plus g of x. And the other three functions are defined similarly. If I want to do f minus g, if I want to find f minus g, I have to tell what the input is, that's x, and if the input is x, then f minus g of x, you get it by plugging x into f, plugging x into g, and then subtracting the two. So f of x minus g of x. For f times g, again, your input is x, and your output is going to be f of x times g of x. And then for the function f over g, your input is x, and your output is f of x over g of x. So just doing an example with some functions given by formulas. If I wanted to find f plus g of x, well, I've got to tell you, I have the input x. I just have to tell you what the output is. Well, you plug x into f to get x squared plus 1. You plug x into g to get x plus 2, and then you add those two together. If you want to simplify that, you get x squared plus x plus 3. No need to simplify unless you want to, though. If I wanted to find f minus g of x, well, the input is x, and the output I get by plugging x into f to get x squared plus 1, plugging x into g to get x plus 2, and then subtracting those two quantities. And you can do a little some simplification if you want to, and if you do, you get x squared minus x minus 1. If I don't want to do f times x of g, or I'm sorry, f times g of x, what I do is I plug in x into f and g, multiply them both together, and I could leave it in this form if I wanted to, but if you wanted to multiply it out, that's what you'd get. And similarly with the function f over g, if the input is x, the output is going to be x squared plus 1 over x plus 2. Just dividing the outputs of f and g. All right, so now let's see what happens if we try to interpret these combinations of functions from their graphs. So I'm going to give you the graphs of f and g, and yeah, I should probably tell you which one's f and which one's g. F is the red one, and g is the blue one. And what we're going to do is find f plus g of 2. Now, remember, the input is 2, so we need to find the output, which means since we're doing f plus g, we need to find the output of f and the output of g. Since our input is 2, we want to look for an x-coordinate of 2, and there they are. It's kind of hard to see the numbers, but you can see at x equals 2, there's one above the x-axis on the red graph, there's one below the x-axis on the blue graph, and I will tell you what those points are if you can't see them. For f, the point is x equals 2, y equals 3, which means that f of 2 equals 3. For g, the point is x equals 2, y equals negative 4, which means that g of 2 equals negative 4. So if I want to find f plus g of 2, I'm going to plug 2 into f, I'm going to plug 2 into g, and then add those together. I know f of 2 is equal to 3, f of 4 is equal to negative 4, and when I add negative 4, and when I add those together, I get negative 1. And let's go ahead and do the same thing with f over g of 4. Once again, I'm going to need to find out what the outputs are for x equals 4. And now I want to look where the x-axis is at 4, and that's right over here. And again, you can see right above x equals 4, you have a point on the red, on the f graph, the red one. And then right below the x-axis, you have a point on the blue one. That's the graph for g. And again, I'll tell you what those points are. For the red graph, we get x equals 4, y equals 5, which means that f of 4 equals 5. For the blue graph, we have x equals 4, y equals negative 1, which means that g of 4 is equal to negative 1. And now finding f over g of 4, we're just going to put in f of 4 on top, g of 4 on the bottom. F of 4 is 5, g of 4 is -1, and that gives us -5. All right, and so here's an example of combining functions in a particular application of a function. So here's a situation where you have invested in JoJo's newest dubious business venture. JoJo's into JoJo coin. What can I tell you? And over time, you have some dollar amount of JoJo coins, and over time, you also have a certain number of JoJo coins. So the total dollar value of your JoJo coins at time t is going to be 20t minus t squared. The number of JoJo coins you have in your account at time t, the number of coins, is j of t equals 1/20th t plus 1. And the question is, what is the price of each JoJo coin in your account at time t? So I want a function where the input is the time and the output is not the dollar value of the JoJo coin, but the price for each coin. Now, remember, price is measured as dollars per JoJo coin. So it's the number of dollars that you either pay or have value in for each coin. And what you're going to do is you're going to divide in order to find the price, right? So you're going to take the number of dollars that you have, right, in JoJo coin. You're going to divide that by the number of JoJo coins that you have, and that will give you the number of dollars per JoJo coin. So d of t, you have a formula for that. That is 20t minus t squared. Also, we have a formula for the number of JoJo coins. That is 1/20th t plus 1. And so, for instance, if we wanted to find out what the price was of JoJo coins after 1 day, you just plug in t equals 1, do those computations, and end up with, just under $19 per coin. If you wanted to see what happens after 10 days, you just plug in t equals 10, and you do that computation, and you end up with a little over $66 in per JoJo coin. Apparently, these were the days when investing in cryptocurrency was going really well. Your results may vary. In any case, if you wanted to find the price, given this model, if you wanted to find the price on any day, you just put in the time, and the output would be the price of the coin. All right, so I think you're ready to work on the combining functions activities, and that's on the PDF included with this video.